All right, so this is trigonometry lesson 1, and I'm going to walk you through the practice problems that you've already completed. So we had two lesson goals in this lesson. The first was a little bit of review because we worked with right triangles before, but it was to identify the sides in a right triangle and identify them as the hypotenuse, which of course never changes. It's always opposite the right angle. But also these other two designations, the adjacent side and the opposite side, which you should have noticed they change relative to the angle you're looking at. So if I'm looking at a specific angle, the adjacent side is going to be different than if I'm looking at the other angle. And so that is something we need to be um, aware of. The second thing is that to notice that if I have similar triangles, that those trigonometry ratios, opposite over hypotenuse and adjacent over hypotenuse, they're always the same for similar triangles. So they have to do with the angles of a triangle, not the size of the triangle. So the angles of a triangle determine whether these ratios are going to be the same. So the first problem is all about opposite sides. So how do we identify an opposite side in a right triangle? And so they start with, in yellow here, it says, name the side of the triangle opposite A. So we look at angle A, and we can see that the side that is directly across from it on the triangle is side CB. And so the side that is opposite to angle A is going to be side CB. That, of course, is the same as BC, so either of those answers would be correct. The second question says the side opposite angle B. So here is angle B in red, and it is the side that is directly across from that. And so in red, we would have side AC. And of course, you could call it CA as well. Those are both okay. The last one is the side that's opposite angle C, which is special because that's the right angle, right? So the side that's opposite angle C is also known as the hypotenuse, which we remember from when we worked on the Pythagorean theorem. And of course, we can see that that side is AB. And so we could see AB, side AB, which of course is the same as BA. So however you want to name it. So in problems 4 through 6, we're going to be identifying, they're going to tell us which angle to look at, and then we're going to identify the adjacent, the opposite, and the hypotenuse. Now remember, these designations for the adjacent and the opposite are going to change depending on which angle we're looking at. The hypotenuse will never change. It's always going to be the same. So let's start with the hypotenuse. So I look and I see here is my right angle at D. So the hypotenuse is the side FE. So I'm going to take my pencil and I'm just going to write hypotenuse. Probably always easy to start with that. Then the other ones are going to change. So here I look at angle F is my is the angle, the acute angle I'm interested in. So the opposite side is going to be DE. So I'm going to write opposite there. And then the adjacent side always makes up one side of the angle. So one side is made up of the hypotenuse. The other side of the angle is the adjacent side, and that is the side FD. So I'm going to label that adjacent. So similarly to the last problem, we're going to identify the angle that we're interested in, and they have a little arc marking R. So R is the angle we're going to look at, and we're interested in the hypotenuse. So the hypotenuse is going to be the side that's opposite the right angle. So here's my right angle Q. Opposite that is the side PR. So we're going to label that hypotenuse. And then let's go ahead and label the other side. So I can see the side that is opposite angle R is going to be this QP. So this is the opposite. Now, if you just write OPP, I'm going to know what you mean, and you'll know what you mean. That's fine. You don't have to write it all the way out, but I'm writing it out. And then, of course, the other side, the side that makes up one of the rays of angle R, is going to be the adjacent side. So this is the adjacent side. And again, we have a triangle, and they have angle K that's marked with a little arc. And we're gonna find our hypotenuse. So we look for our right angle. The hypotenuse is going to be JK. So we write hypotenuse. And then we can identify the other angles. So not the other angles, the other sides. So the side that is opposite from K is going to be JL. And then the other side that makes up part of angle K is going to be the adjacent side. And there we go. So in the Desmos activity, it asked you to explore some similar triangles. And remember what a similar triangle is. It's a triangle that has the same shape, but maybe it's bigger or smaller. So if I duplicate this triangle here, and then I look at it, I'm going to make it change shape, right? Or not shape, but size. So I can see these two triangles that I have here are the exact same shape. The angles are the same. They're both right triangles, and that's important as well because these relationships we're talking about are for right triangles. And if they're similar, these angles are the same. So I have this angle here is going to be the same as this one. This angle is going to be the same as this one. And what you should have saw are that the trig ratios, those ratios, if I did opposite over hypotenuse and adjacent over hypotenuse, they're going to be the exact same answer in both of these triangles. So for similar triangles, that is always true. And remember, when we are always talking about right triangles when we're talking about this trigonometry. We're studying right triangle trigonometry. So in the next few problems, we're going to be using this chart. And you can see with this chart, it has the angles listed here. And then we're going to look up each angle measures for the ratio. Because remember, the ratio is tied to the size of the angle. So if I look at this triangle here, that means that I'm interested in angle 53. So the angle I'm going to look at here is angle 53. The rest of the chart I don't even need. And so we're going to answer the question. I want to find the side lengths of x and y. So we're going to set up our equation. So we take and we look at, for angle 53, I'm going to make the ratio of opposite over hypotenuse. And opposite over hypotenuse for angle 53 is going to be y, and here's the hypotenuse. So it's going to be y over 7. And I go to my chart here and I look for opposite over hypotenuse for angle 53, that's 0.8. And so what we're going to say is that y over 7 equals 0.8, because that's what the ratio is. And so then I can solve this by cross multiplying or just multiplying by 7 on each side. So y is going to be 7 times 8, which is 56, but I have one decimal place, so it's 5.6. And so y is 5.6. And similarly for the other ratio, adjacent over hypotenuse, so that's going to be x over 7. I look up in the chart, and the adjacent over hypotenuse is 0.6. So we're going to say that's equal to 0.6. I'm going to multiply by 7. So 7 times 6 is 42. There's one decimal place, so it's going to be 4.2. And we're done. So in this problem, the second one of that type, we're going to look at angle 30. And so angle 30, we are going to look, and z is the hypotenuse. And I need to look at the ratios for a 30-degree angle. So we can go and find 30 degrees here. And there they are. And the first ratio, if I look at, I'm going to use a black pen. So if I look at opposite over hypotenuse, is going to be 9.2, that's the opposite side, over z. And that ratio, so opposite over hypotenuse is 0.5, so this would be equal to 0.5. And then I need to solve that equation. So to solve this equation, you can think of cross multiplying. I can put a 1 underneath here. But in the end, what I'm going to do is I'm going to be taking, and I'm going to have this for my final answer. I'm going to have z equals 9.2 divided by 0.5. And so when I solve this, I'm going to get 18.4. And so this is equal to 18.4 for the hypotenuse. Now, once I have the hypotenuse, then it's going to help me when I do the next one, because I know this hypotenuse length now, 18.4. So let's go ahead and do the second part, and that is the adjacent over hypotenuse. So if I take the adjacent side over the hypotenuse, that's going to be, for my table here, 0.87. So this is going to be 0.87. And so we have x over 18.4 is going to be equal to 0.87. And so all I need to do is multiply 18.4 times 0.87. And so x is going to be, so x is 16. Now, brings up an important idea that if I'm finding these ratios of opposite over hypotenuse, adjacent over hypotenuse, it's really helpful to know the hypotenuse. So it might be helpful to start by finding the hypotenuse, whichever one of these you choose to do, opposite over hypotenuse or adjacent over hypotenuse. It might be pick something to find the hypotenuse first, and then once you have that, then you can use that in your next calculation. So in this situation, again, we don't know what the hypotenuse is, and we're looking at angle 67. So if I look up angle 67 here, we have the ratios of 0.92 and 0.38. So let's start with the opposite side, because we know the opposite side here is 21.6. What would be the problem if I tried to start with the adjacent side? Well, I would have adjacent is x and the hypotenuse is z. I don't know either one of those. So then I'm kind of stuck. So we do know the opposite side. So that's the ratio to start with. And so we're going to say opposite over hypotenuse. And if I look that up, that's 0.92. So 0.92 is equal to 21.6 over z. And so then I could put a 1 underneath there and cross multiply. It's going to give me this for the answer there. I'm going to have z equals 21.6 divided by 0.92. And that gives us 23.5. So we're rounding to one decimal place. So this would be, z would be 23 point, it says 23.478, it keeps going. So 23.5, rounding to the tenths place. So this is 23.5. All right, so now we know the hypotenuse. It's going to be real easy to find the other answer. So we have adjacent over hypotenuse. And that ratio is 0.38. So 0.38 would be the ratio of the adjacent side. And for this angle 67, the adjacent side is x. The hypotenuse is 23.5. So we'll say that's equal to x divided by 23.5. And so x is going to be, if I take 23.5 and multiply it by 0.38. And that gives us 8.9. So x is 8.9. And again, it gives me more than 8.9. It says 8.9217. And so we're rounding to the nearest tenth in this case. So the adjacent side is 8.9. Yeah. The last problem is an application problem. And you can see, first of all, in these problems, look for a triangle. So we can see the triangle here. And the idea is that you have somebody standing in front of a building. So here's the person would be down here at that vertex where you have 41 degrees. And they want to measure how tall this building is. This is a real world application of how you could use trigonometry. And so obviously it's hard to measure a tall building, you can't get out a measuring tape, but I can certainly measure how far I'm standing from the building. And I can use special tools to measure this angle, and they tell you it's 41 degrees. So based on the angle, they say the angle is 41 degrees, so I can look and say, okay, if I'm using a 41 degree angle, what should these ratios be? And the ratio I'm looking at here is the opposite, and I need the hypotenuse for these. I don't know the hypotenuse. So I can't use the opposite over hypotenuse right away. It might, to get me started, I'm going to have to use the adjacent and the hypotenuse. Once I know the hypotenuse, then I can go ahead and use the opposite over hypotenuse to find the height. So let's start with the adjacent over hypotenuse. So adjacent over hypotenuse ratio, and that is 0.75. So I'm going to say, okay, 0.75 is going to be equal to the adjacent side, so I'll call the hypotenuse x. The adjacent side is 120, so I'm going to say that's 120 over x. And so to solve this, I'll cross multiply. You can put a 1 underneath here, but your answer is going to be x equals 120 divided by 0.75. It turns out to be 160, in this case meters, because we're measuring in meters. So this is 160 meters. So this is 160 meters. And now we can go ahead and actually find the height, which is what we wanted to find. So I have opposite over hypotenuse. And the opposite over hypotenuse, the ratio is 0.66. And so the opposite side is y. And before I would have had to put an x here, but now I know what x is, so I'm not stuck anymore. I can put 160 here. And so now I can solve this, and y is going to be 0.66 times 160. So if I multiply those out, I get 105.6. So this 105.6 means the height of this building is 105.6 meters tall.